Hello, this is a valve amplifier. It's a Laney Pro 100 watt amplifier, and it was bought by a friend of mine on a car boot sale, and it was raining, so it was all quite wet and damp, and you daren't switch it on. We've kept it downstairs for a couple of months just to give it a chance to dry out, and now it's on the desk. Now if I switch it around, you'll see on the back here already one of the fuses are missing, the fuse for the HT. So, you know, it's not going to work until we start having a look at it and seeing how it works. I'm not that great on valve amplifiers. I don't know a heck of a lot about them, so this is going to be a bit of a learning curve for me as well. So let's get a look inside of it, shall we? Right, I'll take this back off. This is very sharp, it's almost like a saw, that is. And there's your amplifier. Under here it will be your little preamp tubes, valves, vacuum tubes, whatever you wish to call them, and these are your main amplifier tubes. Now there's a lot of wildlife and cobwebs everywhere, and I hate this sort of stuff, so I'm going to give it a little hoover out and then take this section out and we can have a better look at that. Now before I flip it over and start having a general look at what's going off in here, I'm going to take out all the valves and put them in a safe place so I can swing this around without damaging any of these. So I'll pull these out and give them a little sort of a circular motion as they come up. It just makes them a little bit easier. Now on the bigger valves with these strange clips, if you just push those down, I don't know if you can get that in the camera, push them downwards like so, grab it at the bottom, and out they come. These will have a little key lock in them, so you can only put them back in one way. There you go, put them to bed. Okay, the transformers have got a lot of rust on them, and it looks like there's been a bit of water damage. Maybe I'm wrong, I'm not too sure, but it looks like water damage to me. Yeah, it doesn't look so fantastic. Let's flip it around. Just make sure I can put it on that piece there. It's very bloody heavy, this thing is. Now thankfully these capacitors have got drain resistors on them, so they'll slowly drain off the power that they've stored, and there's less chance of you getting a massive zap on it. If you just leave it for a while after it's been unplugged, then you should be okay. But I can't stress how important it is when you come to something like this, on how careful you have to be when you power it up, and also for a little bit of time after it's been powered up, because these capacitors will hold a charge for a while, and it's not very nice. That's why I don't like working on high voltage stuff like this. Now if you do start working on high voltage stuff, one little trick that some people would tell you is use one hand. Put the other hand away. You don't need that. Use one hand all the time. That way you're not going to get a shock going up and across your heart and the other way, and yeah, it's just a safety thing. You should use one hand, or get a decent pair of gloves at least. Anyway, moving on, let's have a look into this. Looking at the board, it's yeah, apart from that 4-watt resistor there, which has been cooking a little bit on the board, but that's okay, that's no problem. These capacitors are very interesting. They're 3-pin capacitors, and what it is, they're 500 volt capacitors made by LCR, a British company a long time ago, and you've basically got 50 microfarads there and a 50 microfarad capacitor there, and because they're linked across in parallel, it makes a 100 microfarad capacitor. Interesting. Now then, this is the fuse holder that I'm going to have to unsolder, take out, put a new fuse holder in, and then we'll fire it up and see what happens. I've changed the fuse holder. Unfortunately, I didn't have the correct one, but another one that would do the job. These were quite awkward because they were glued in as well. Right, I've plugged it in, but I've gone through the variac for the moment because I'm just going to run half the voltage to it for the time being to see if any of the components heat up really quickly. I'm going to use this little tool here and just check on the board and see if anything starts smoking first, and then I'll bring the voltage up to 240. So now remember, I don't want to win any Darwin awards here, so you must always be careful what you're touching on the board. And that switch is so bloody stiff. Ah, got it. Okay. Okay, there's a diode and that 4 watt 1k resistor that's heating up nicely, but nothing else looks too bad. Let's ramp the voltage up and get ready for the magic smoke. It's not pulling any amperage at the moment. Now I'm at 240, full voltage. There's no amperage being pulled, so it's not under any major stress just yet. Yep, that resistor's getting hot, but 89 degrees Celsius. Right, okay, we'll switch it off. And now I'm going to put in the valves. Because this has been turned on now, those capacitors are going to be charged up. So this is where you have to be really, really careful what you're handling when you're trying to repair something like this. You know, treat it always that this thing's going to kill you if you touch the wrong part. These are the preamp tubes, and these are ECC 83s. They're also known as 12AX7s. Now these are high impedance amplifier dual triodes, and they're designed for audio use. They've got a high amp factor of 100. Inside there is 2 sets of anode, grid and cathodes. Now these bigger ones here, these are EL34Gs. These particular ones are made by Sovtech. This is an equivalent to a 6CA7. This is a power pentode. Now, in an amplifier, an AB push-pull type amplifier, these would normally run at 420 to 500 volts plate voltage and will produce 100 watts output. So this is sort of typical for many guitar amplifiers. I've got a 440 Hz middle A going into the amplifier. That's in the yellow there. And the green is what's coming back out. Now the cabling isn't very good to represent what's coming out here. It's all a bit of a mishmash. But here you go. I mean, it sounds okay. Looks a bit more of a sawtooth there. But that could be down to the way I've connected the scope up to the amplifier. That's the bass in the middle and the trebles going off. That shapes the waveform a bit. But yeah, there you go. It makes a noise. Now this amplifier has a load impedance selector. You can have 4 ohms, 8 ohms or 16 ohms. This was originally set on 4 ohms. I've only got a couple of small bookshelf speakers and they're both 8 ohms each, but I want to use the 4 ohms still. Now to do that I would have to put them in parallel, because 2 times 8 ohm speakers makes 4 ohms, or 2 times 4 ohm speakers makes 2 ohms. Now if you put them in series, 2 times 4 ohm speakers would make 8 ohms. and 2 times 8 ohm speakers would make 16, which isn't so great. If you have 4 speakers and you do them in what's called a series parallel configuration, 4 times 4 ohm speakers still makes 4 ohms. 4 times 8 ohm speakers still makes 8 ohms. There you go, it's all back in its box now. It's a bit dirty on top still, but that's not my job. I've cleaned it all up inside, and as you know, it had got wet, and all I've had to do is change the fuse holder for the HT, and I've cleaned up all the pots and things, you know, the usual service stuff. I've done a pat test on it, or pack test rather, and yeah, it's all okay and working. Well, as far as I know, I haven't got a guitar, but it's working anyway. I can't stress how important it is if you get into something like valve amplifiers. The voltages in there can kill you, and even if you plug it in and unplug it, the capacitors in there can hold a pretty nasty charge. So always be careful if you decide to get inside one of these things. But anyway, other than that, thank you very much for watching. If you did like it, please give us a thumbs up, and another video on the way soon. All the best.